All right, I wanted to run through another example of finding the confidence intervals for regression. On this one, it says, based on the data shown below, calculate the parts that would be used for a 95% confidence interval. So our confidence level is 95%, which means our alpha is 1 minus that, 0.05. And we're going to need to know n and our degrees of freedom, and then also m eventually. We're supposed to calculate the round our values that we're going to find these guys to 3 decimal places, and then in the end here, our confidence interval is going to go to 2 decimal places. So I'm going to just grab the data here, maybe. Try this from the bottom up, and I'll paste it special. And we'll see here, okay, now the number of pairs of data I have, 15. And our degrees of freedom will be that value minus 2, since we're dealing with bivariate data. We're going to subtract 2. And then our slope. Go ahead and use the slope function in Excel, and we can get the known y's and the known x's. There. We can find the slope the other way. Don't know what I did there, but this works pretty quick, and it gives us some decimal places of accuracy. So using the slope function. Now to find those other things, we're going to need x squareds, y squareds, and xy's. The wheels are falling off the wagon here. We got a y squared here, hopefully, and now it's a hyperlink because we added something. So anyway, we're interested in finding all of these, so I'm going to go ahead and write these down here. SS sub x and SS sub y, and then SS sub xy. Our standard error, our critical value, our error bound, our margin of error, and then actually I'll use the lower and the upper to find the actual value there. So, okay. For this one, we'll take our x value and we'll square it. We'll take our y value and also square that. And then the product of x times y. And if I grab all 3 of these, double click here, magic should happen. And I'm interested in those sums. So I'll start calculating the sums. And then I'll drag it over. I have all those. So now we're going to start calculating these pieces, and I'm going to go ahead and bring my formula sheet up. Just don't have them all committed to memory yet, and you don't need to either. So it's the sum of all the x squareds, that's this column, total, minus the sum of all the x quantities, and those get squared, and then we divide by n, which is up here. And we get 280. Similarly for the y's, we grab the sum of all the y squareds and we subtract the sum of all the y quantities squared. And then we divide by n. Oh boy. Oh boy. What do I want here? E25. The C29 is just being extra. I'm having the hardest time with this copying here. Okay, easy for me there. Now it's the sum of all the xy's here minus the sum of all the x's times the sum of all the y's, and then we divide by n. Now, to figure out our standard error, that's down here, it's going to be the square root of, and I need some grouping symbols for the top. I've got this SSY minus M times SSXY, and all of that gets divided by n minus 2, which is the same as our degrees of freedom, so I'm going to just snag that. And yes, please add that for me. Critical value, this is a t-inverse, it's two-tailed. We need our alpha and our degrees of freedom. Oops, forgot to copy these guys over. Showing my work here. Now the error is a little bit to it. We have actually here the t alpha over 2, that's the critical value multiplied by the standard error, and divide by the square root of SSX. So the standard error, and then divided by the square root of SSX. This guy. Almost done. The lower limit is going to be our slope minus our margin of error. And then the upper limit is the slope plus. I'm just copying that again, and I'll change the sign to a plus here and hit this. And then copy this to there. And now for the fun part, entering our responses here. 280, 2201.17. I think they wanted these to 3 places, so I'm going to go ahead and drag that over. We got a 3, negative 783.1, 0.9203. Our critical value, 2.160. Our error, 0.119. And then our interval, negative 2.92. Since that 5 is going to make the 1 go up, and 2.68. And the moment of truth. 1.71. Well, we missed something along the way here. Kind of interesting to get all of these. 6, 7, 9, 2, 9, 1. Given answers in open interval rounded to 2 decimal places. You see negative 2.91. Oh. Yeah, kind of need a negative there. Big difference, I was going to say. Okay, so quite a bit of process here. Now, occasionally the formula will break down. If you start getting negative values in these guys and you get a standard error that doesn't compute because of negatives, unfortunately, I haven't figured out how to fix the code so that doesn't happen super occasionally, which is like quite infrequently. But if that does happen to you, feel free to skip the question and message me. If you make a mistake in here, you won't get the points. But if you happen to have done it all correct, it just occasionally happens. It actually happened when I was making this instructional video for me. So little errors, still some bugaboos to work out to our free program. But show your work clearly. If you have any questions, feel free to message me your spreadsheet. I am getting some questions, but not all of them with work shown. So please take the time to message me your spreadsheet, show your questions. Let me know if you have any more. I might work out some more, but for now, you should be good to go on these questions. Good luck.